Hello, so today we will talk about spectrum number 7. If you see the spectrum number 7, your first goal is to see the mass spectrum. In the mass spectrum, the molecular formula of a compound is given, which is C4H4N2. So whenever you are going to say the molecular formula, your first task should be to find out unsaturation index or degree of unsaturation. So the formula to find out unsaturation index or degree of unsaturation is 2C plus 2 plus N minus H minus X divided by 2. So C number of carbon atom, N number of nitrogen atom. So let's put the value of carbon 2 as it is. How many carbon? 4 carbon. So put 4 plus 2 according to the formula. How many nitrogen atom? 2 nitrogen atoms. So put 2. How many hydrogen atom? 4 hydrogen atom. How many halogens? There is only one zero halogen in this compound. So put 0 divided by 2. So 4 times 2, 8. 8 plus 2, 8 plus 2. 10, 10 plus 2, 12, 12 minus 8, 12 minus 4 divided by 2. So 12 minus 4, 8, 8 divided by 2. You will get the degree of unsaturation, which comes out 4. So it means the degree of unsaturation of this compound is 4. It means might be the compound contain benzene ring. Possibility. Let's see whether the benzene ring is present or some other functional group is present. So degree of unsaturation of this compound is 4. Let's keep this in mind. Now let's move towards the IR spectrum. This spectrum is known as IR spectrum. In IR spectrum, this region, the region below 1600, this region is called fingerprint region. Fingerprint region is less important, does not provide any information about the structure of the compound, unknown compound. This region, starting from 1600 to 4000, this region is known as diagnostic region or functional group region. Many important functional group are going to lie in this region. So if you see the diagnostic region, there is a signal, there is an absorption at the range of 20 to 49 centimeter inverse. So this absorption related to mostly carbon-carbon triple bond or carbon triple bond nitrogen appear in this range. Which range? 2300 centimeter inverse to 2100 centimeter inverse. Mostly carbon-carbon triple bond or carbon triple bond nitrogen are going to appear in the IR spectrum of the compound. So from the IR, we are going to find out this compound contain might be carbon-carbon triple bond or might be carbon triple bond nitrogen. As nitrogen is present, might be carbon triple bond nitrogen. We will sort out soon. So it means the possibility of benzene is ruled out because this compound contain carbon double bond nitrogen. Degree of unsaturation is 4, so benzene is ruled out completely. Okay, now we are getting a signal. This one, this is again, I told you, I repeat several times, this is sp3ch stretch, and most of the compound contain this signal. So degree of unsaturation for IR provide information whether the carbon-carbon triple bond or carbon-carbon double bond. If this is a carbon-carbon triple bond, then and it is a terminal carbon-carbon triple bond, and you will get a signal of SPCH stretch. SPCH stretch appear in the IR spectrum in the range of 3300 centimeter inverse. If you see 3300, 3100, 3200, 3300, this region is empty. It means the possibility of terminal alkyne is ruled out as well. It means the possibility of carbon-carbon triple bond is also absent. So there is only one possibility, that is a non-compound contain carbon triple bond nitrogen. So let's move towards the carbon 13 NMR. How the carbon 13 NMR help us? So if you see the carbon 13 NMR, there is a depth spectrum of the compound is given. If you see the depth spectrum, so there is only one signal. There is only one negative signal, and the signal is belong to CH2 signal. While rest everything is empty. There is no carbonyl group, no other functional group is present in this compound. So proton decoupled spectrum. In proton decoupled spectrum, you are getting the two signal. First one is CH2 signal, and here you are getting a signal which is in the range of 120, 115 to 120. This signal might be carbon, triple bond nitrogen, quaternary carbon mostly appear in this range, quaternary carbon. Okay. So let's move finally to the proton NMR spectrum. Proton will provide you the exact answer of our question. So if you see the proton NMR spectrum, there is only one signal, and the signal is this one. Because if you see the molecular formula of a compound, the molecular formula of compound C4H4N2, C4H4N2, there is only 4 hydrogen. So these 4 hydrogen are, what's the multiplicity of 4 hydrogen? Singlet. These 4 hydrogen are giving you singlet. It means you have to keep the environment same. You can't attach 4 hydrogen with a single carbon because it will become a stable molecule. Then how you will connect nitrogen with that carbon, how you will connect rest of the 3 carbon with that carbon. So it means now you have to keep the environment same. And how you will keep the environment same means the compound is symmetrical in a simple way. 4 proton singlet. How you can make 4 proton singlet? CH2, CH2. 2 carbon done, 4 hydrogen done. Now you have 2 carbon and 2 nitrogen. Still degree of unsaturation 4 is remaining. Now you have to keep the environment same as well. How you can keep the environment same? Like if I'm going to put here, because IR told me there is a possibility of carbon triple bond nitrogen in this compound. So if I'm going to put carbon triple bond nitrogen in this compound over here, now the molecular formula becomes C3H4N. Still 1 carbon and 1 nitrogen, and degree of unsaturation is 2. So how you will make, because the compound is symmetrical, means so the left hand side and right hand side should be the same group. So the left hand side should contain the cyano group as well. If you see this compound, the molecular formula of this compound is C4H4N2. The degree of unsaturation, because this compound contains 1 to 2 pi bond over here, 2 pi bond over here. So total 4 pi bond are present in this compound. So the degree of unsaturation of this compound is 4, not 6. Triple bond, degree of unsaturation 2. 2 over here, 2 over here. So degree of unsaturation is also complete. So these 4 proton, because their environment is same, so they will give you a singlet in the range of 2.6 ppm or 2.7 ppm. That's the unknown structure of this compound. If you want to move further, like here in CH2, CH2, C triple bond N, C triple bond N. So these 2 carbon, they are giving you this signal. While this signal, the second signal is this cyano group, this one. These 2 carbon are giving you the same signal because the environment is same. So both of these carbon are symmetrical. Okay. If I'm going to move the mass spectrum, how you will explain the mass spectrum? So you are getting a signal in the range of M over Z is 80. Molecular ion peak is going to appear in the range of, nitrogen has a 1 lone pair. If I'm going to remove 1 hydrogen, 1 electron from here, so you will get this molecular ion peak. It is going to appear at M molecular weight 80. So if you are going to remove 80 to 53, you are going to remove 27. Loss of 27, how you can, nitrogen 14 plus carbon 12, it will become 26. It means you have to remove 1 hydrogen as well from here. So if you are going to remove this fragment from here, you will get a signal which is this one, CnCH2, CH positive. So this signal appear is going at the range of 53 m over M53, and this is the molecular ion peak of this compound. Molecular ion peak of this compound. So again, if you are going to remove 1 more HCN, 1 more CH, you will get a signal at the range of 40. So this is how you are going to explain the mass spectrum of this unknown compound. So I hope you have enjoyed this lecture. Please like, subscribe, and share this channel. See you in the next discussion. Wish you best of luck.